Today, we are going to look at what caused the huge change of direction in the graph of world population. Natural changes tend to be a slow change of direction. So, for example, a more typical graph showing a natural change would be a 45-degree upward slope, like the picture below. You might think that if there is no contraception, parents will always have about the same number of babies because they have no control over it. Clearly, there have always been some methods of contraception, but they were unreliable, except for going without. Assuming their levels of use within the population and the percentage of times they didn't work were both unchanged over time, the average family size would stay the same. Research shows this to be broadly true, with the fertility rate being about 6 babies per mum. There are a few things that can influence it, like how old people are when they get married, and how many people, like monks, are celibate. But generally, the number won't change much because of time or location. The opposite view is based on what we see in nature. For example, insects. If conditions are good, the birth rate will go up. If you move a beehive from a place with no flowers to a place surrounded by flowers, the bee birth rate will go up. Human populations behave the same. If times are good, birth rates will rise, and they will stay the same or go down if times are bad. To be exact, they don't rise because times are good. They rise because they are improving. If times are good, birth rates will rise for a while, but then stop rising because they reach the highest level that is sustainable for the conditions. So when it reaches this mature phase, times can be good, but population stays the same. As long as conditions keep improving, growth will continue. Once conditions are no longer improving, even if that is because they are already extremely good, growth will end. Improving conditions are always temporary and not sustainable. Once the potential for improvement is used up, birth rate will stop going up. If this happens, it will stay the same. If conditions get worse again, there will be a period in which birth rate falls back towards a new balance. This may mean deaths, but more often just a reduced birth rate. There can, of course, be lags where it takes several generations for change to be enough to match the new conditions. So we have here a diagram of the human population response to technological improvements. So we start at the top with the static population, and then moving to the right, we have a technical innovation. In this case, we're going to use the example of windmills. So we have the first windmills. Continuing, this it saves time that can be used to grow more food. Because of more food, nutrition is better. Because nutrition is better, more babies survive. Because of these things, population increases. Then moving to the left, increased population means we need more food. And more food means growing more. And assuming we have already using the best land at the moment, the land we will use for growing more will be worse land. So now we are using the time that we saved from the windmill to grow more food. So the time saving is lost. Food production per person goes back to the earlier level, and the population stops growing, and we're back to the top again with static population. How can we reconcile these two ideas? The first one, that birth rate will always stay about the same because if there is no contraception, there is no control. And the second one, if things are getting better, birth rates will rise. If they get worse, they will fall. The answer seems to be that people are more likely to want more children if their life is comfortable and they don't have to work too hard. This tendency can be seen in rural or agricultural populations. The number of conceptions is lower at planting time and harvest time when workers are working very hard, and higher between those events when work is slacker while the crops grow. Fewer people will use the imperfect contraception, which increases the number of pregnancies. Better nutrition for mothers means more chance of conceiving and more chance of a trouble-free pregnancy and birth. This improved nutrition also reduces death at an early age. Generally, we can say that the opportunity to improve the fertility rate is small because in a world of only very basic contraception, the rate is already high. The factors above influence rates of pregnancy and live births, but the major factors changing population numbers are not changes in the number of births, but in the number of deaths. The first argument about contraception is important because it means that when we are trying to explain a big shift in population, we can forget about the number of births. They will always be about the same. We have to look at the other side, the number of deaths, to explain population changes. The second idea says that the birth rate will explode like this if their situation is improving, and especially if getting food is easier, as with the example of the bee populations. Following that logic, you would say that something extraordinary must have happened to humans around 1750 to 1800 that made their situation a huge amount better. Many families had more children because they felt comfortable that they would be able to feed them all. So the conclusion so far, increase in population is a response to improving conditions. This could be new technology like windmills or water wheels, or climate change that makes growing things easier. So far, so good. But that doesn't explain why population can keep rising at the amazing rate it has been since 1800. The usual answer given is that it was due to the Industrial Revolution and the Agricultural Revolution at about the same time, starting around 1750 in Britain. The Agricultural Revolution meant that we could grow more food on the same amount of land. The Industrial Revolution meant we could make many things quicker, cheaper, and using fewer people. Then, when we were about 50 years into these changes, we started to use fossil fuels to provide energy to make it all work. Before that, we had been using water power, but that reduced the number of places where things could be done because you had to have plenty of water and hilly country where the water was falling a long way. With fossil fuels, mainly coal, you could put your factories in many other places and closer to where people lived. These were very big changes, but are they enough for what is shown on the population graph? Also, just because they happened around the same time doesn't mean that there was cause and effect. Can we believe that these events, which at that time were only happening in a small corner of the world, could produce the result shown on the graph? If countries with around 7 or 8% of world population experienced the industrial and agricultural revolutions, and the rest of the world was continuing as before, the graph for the rest of the world would still be flat, and the graph for the few countries where the changes were happening would be near straight up. The impact on the world map would be small, since the percentage of the world population going straight up was small. The second factor is that the revolutionary changes would have to be continuous. If, for example, they occurred between 1715 and 1800, and then the rate of change slowed right down, the graph would look like this. So pre-1750 it's flat, and then it climbs between 1750 and 1800, and then it stops climbing after that because the change is over. This is an abstract from an article called Population Change 1750 to 1850 by Michael Anderson. Quote, in 1750, the population of Northwest Europe was between 60 and 64 million. By 1850, it was around 116 million. This dramatic expansion was not evenly spread across the continent. At one extreme, Finland's population almost quadrupled, times 4, in this period. And before its collapse in the famine of the late 1840s, Ireland's population grew about 3.5 times. At the other extreme was France, and probably Switzerland and Netherlands. France in 1750 had 2/5 of the population of our area, but her population seems to have grown by less than 50% to 1850, reducing her share to 3/10 of the total. Between the extremes, the population of England and Wales expanded 2.9 times, from 6.1 million in 1750 to 17.9 million in 1851. What? This doesn't fit our idea at all. The fastest population growth was in Finland and Ireland. Both countries are at the very edge of Europe and with agricultural, not industrial based economies at that time. In fact, Irish industries like textiles were shrinking because of cheap imports from the industrialized UK. Certainly, Britain was growing very fast at 2.9 times, but this was in the middle of the pack, even though they were way out in front with industrialization. France was some way behind Britain on industrialization league table, but still at number 2 or number 3, and they grew significantly slower than the average European country. Everything about the Finnish and Irish, the British and the French numbers seems to say that there is not a strong link between industrialization and population growth. It still leaves the question wide open: what was the cause of the exceptional strong growth in Finland and Ireland? In 1750, the world population was 814 million. Europe was 60 million, which was equal to 7.4%. In 1850, the world population was 1,850 million, up by 127% from 1750. Europe was 116 million, up by only 93%, and Europe was about 6% of the total. This may be understated because around 50 million people left Europe to go to other countries like the USA. If we add back this 50 million, the growth figure for Europe is about 177%. However, if you believe the idea that population growth is a response to improved conditions, the emigration issue is a two-edged argument. People generally are happy if their situation is improving and do not undertake a long and dangerous sea voyage to a new country, however strong the attractions of the destination are. The population outflow therefore implies unsatisfactory conditions in Europe. Overpopulation. Overpopulation implies that things have got worse. Families expanded because times were good, but then bad times arrived, causing the outflow. This is not consistent with the idea that the European population expanded because conditions were more favorable to having children there. The picture shown is that European population did expand faster than the world as a whole between 1750 and 1850, but there was no way the difference was big enough to have a major influence on the world number. The bottom line is that there must have been a major increase in population happening in parts of the world which were not industrialized. This is supported by the European data, which shows the strongest growth in Finland and Ireland, agricultural countries, much stronger than the main industrialized country, Britain. If we look outside Europe at the period from 1750 to 1850, the Chinese population increased by 94%. This is almost the same as Europe's 93%. But Europe was industrializing and China was not. Moreover, in China, the fastest population growth was in rural areas due to crops which would grow on more marginal land, not in the cities. The conclusion is that the population explosion was also strong in the non-industrialized world, which should not surprise us because it's exactly the way it still is today. We can also use this idea that improvements in living conditions will cause population increase in reverse. If we look at where population is increasing fast, we can learn where the situation is improving.
Remember, this is about the rate of improvement, not about where conditions are best.
So here's a graph of population growth from 1950 to 2021. The red line at the top is China, the green line in the middle is India, and the blue line at the bottom is Africa.
The African growth is less expected than India and China. In China, for example, we know that 300 million people have been raised out of extreme poverty in the last 30 years. The position in India is similar. That fits well with the idea that population will grow fast if things improve fast.
This graph is only looking at what has happened since 1950, but it shows clearly the three big areas driving the world population growth: Africa, India, and China, in that order. All of them are at a similar level in 2021, but Africa started from a lower base in 1950, followed by India, slightly higher, and then China, the highest of the three at that time.
In Africa, the improvement, measured by things like GDP and the number of people in extreme poverty, has not been anything like as strong as China and India. Nevertheless, the population has grown faster. Maybe we are looking at the wrong statistics to calculate whether things are improving.
This is the same graph, but we have added three other parts of the world: Europe, North America, and Latin America. So you can see those at the bottom. The highest of those three is Europe, and then Latin America, and then the one at the bottom is North America. They are all much flatter. Europe is almost completely flat. Latin America is growing, but nothing like as fast as China and India and Africa, and the same for North America. In Europe, growth is close to zero and would be negative except for immigration. North America is also low, and most of the growth would also be from immigration. Latin America is in between and would be stronger except for emigration. All of this is consistent with the idea that growth is a response to improving conditions. The exception is Africa, and the suspicion is that even there things are seen by the population as improving, even if it's not reflected in the statistics we follow.
For example, many people think our definition of extreme poverty only in terms of money is wrong. Experiments have shown that people classified as extremely poor don't always use extra money to buy more food, as researchers predict they will.
So, the summary, the graphs should confirm the idea that population growth follows improving conditions. We still don't have an adequate explanation of the picture that the world population graph shows. We don't know why population was expanding at a rapid rate outside Europe and North America. Starting roughly at the same time as the Industrial Revolution, there was a major geographical expansion of the human race into areas underpopulated like North America, Australia, South Africa, Argentina, and into Siberia. This living space availability correlates well with the population explosion, possibly better than growth in productivity. So too does access to natural resources, whether they were in these new areas or older, better known areas. Colonialism proved a very efficient way to extract resources, like teak in Southeast Asia. It was already a known resource, but colonialism was a governance structure that allowed it to be extracted and exported quickly and efficiently. Malthus, writing in 1778, set out his famous theory. It said that population growth would always be faster than growth in food production. This was based on the idea that population grew exponentially. So, for example, if two parents produced four children in the next generation, those four children equal to two sets of parents. If they each had four children, the sequence would be first generation 2, second generation 4, third generation 8, and the number would double with each generation.
Meanwhile, if food production grew by 10% a year, it would go 100, 110, 121. Because of these differences, population would double while food would go up by a fixed percentage. Malthus argued that population growth would always be bigger.
This resulted in his famous saying, quote, "The poor will always be with us," unquote. This idea hurt a lot of people. The rich people used this saying to say that there was no point in helping poor people. If you fed one poor person, it was only by taking food away from someone else. There could never be enough food for everyone. Until the start of the Industrial Revolution, about 40 years before he was writing, what he said was true. Every time there was a famine or a natural disaster and a lot of people died, people's standard of living would go up for a few years because there weren't so many mouths to feed. But then population would grow and the extra food would be used to feed them. So the amount of food per person went back down. So this is the diagram. It's almost exactly the same as the one we looked at before, but this is about the response to famine. So we start at the top with static population. The famine comes, moving to the right, or the disease. The population goes down because there's less people to feed and better nutrition or less work, because they can use only the best land to grow food. Because of that, there's more babies, or more babies survive, and the population increases. Because the population increases, there's more food needed and more time to grow food because now they have to use land that's not so good. The time saving and the better nutrition that they had earlier is lost, and the food production per person goes back to the previous level. The population stops growing, and we're back again to static population. The economic historian Gregory Clark sums it up well. Quote, "In the pre-industrialized world, technological advance produced people, not wealth. In other words, the population increased, but people weren't better off." Let's look at this from the opposite direction. There are only two mechanisms through which change in population occurs. Firstly, the birth rate, secondly, the death rate. They are not causes, they are mechanisms which can be triggered by other forces, which are the underlying causes. What has happened to the death rate? The number of children who survive has been improving rapidly. Pre 1800, there were 6 babies born per woman and 4 died. By 1950, this was 5 babies per woman and 1 died, causing a population increase. Now, the number of babies is around 2 per woman and the number of deaths is insignificant. Nowadays, the death rate among children is so low it's no longer a major factor in population change. At the same time, the age at death is increasing. Part of the older average age at death will be because the children aren't dying anymore. But even excluding the effects of children living longer, for example, by only looking at the age of death of people who reach the age of 30, the older age at death is causing an increase in population. So, summary so far, the changes in the death rate are more responsible for the change in the shape of the population graph than changes in the birth rate. Let's look again at the human population response to technological improvement diagram that we looked at before.
The right side leads to extra population and the need for extra food production. What if at that point, before the rest of the cycle occurred, there was a new innovation? The left side of the cycle would continue for the first change, but the right side would start again for the new change. That, in effect, is what has driven the massive population increases. The improvements in food production and in technology have come so fast since 1750 that the population keeps going up. But that doesn't mean it can go on forever. We know it is already coming up against limits like natural resources. The waste products from our way of life, like CO2, will also limit population growth. Also, as we improve our lifestyle, the level of improvement from each new change reduces. Economists call this reducing marginal returns. Let's look at an example. Back in the 1700s, the number of people dying of smallpox, which is a very bad disease, in Europe was very high. Let's say, for example, that 1 million people died every year. Then they found a vaccine which prevented the disease. Using the vaccine reduced the number of deaths in Europe to 0.2 million each year. After that, they could find other ways to reduce the number of deaths from smallpox, but they could never find another one that would cut the number of deaths by 0.8 million. Every new method only had the opportunity to make smaller and smaller progress because the number of people still dying was getting smaller and smaller. So the improvements got smaller because the opportunities got smaller. This is happening on a global scale. So the level of improvements is limited by the opportunity as well as natural resources. People have been predicting for a very long time that world population would stop rising for various reasons. So far, they have all been wrong. That should make us careful about the next prediction that human population will peak. Humans have been amazingly creative in finding new technological improvement and particularly about growing more food. Food growing improvements mean the left side of the response diagram is weaker. In the rest of this course, we will be looking at some of the reasons why experts still think population will stop growing. These reasons don't have much to do with the rate of improvement slowing or running out of natural resources. They are mainly about humans choosing to have less children than in the past. We'll save that discussion until later, but think about it. The idea is almost as amazing as the population graph turning from horizontal to vertical in the past. Researchers are predicting that people will choose to have fewer children. On one level, it's easy to believe. We see it happening around us every day. There are not many cases where people have more babies than their parents did. But we are saying that maternal and paternal instincts, the instinct to be a mother or a father, are not strong enough to keep the population at a stable level. That's amazing. Those instincts are baked into us at a very basic level. What happens to species that don't have a strong enough maternal or paternal instinct to keep the population stable? They become extinct. So, by definition, we must have in our DNA maternal and paternal instincts that have ensured in the past that humans survive as a species. If this wasn't true, humans would not still be around. Is it believable that we have changed from a species with those baked in instincts needed to survive to one where parents will deliberately choose not to have enough children to keep the human species going? We will continue this debate throughout the course.